Let a and n are two natural numbers, okay? A and n. So suppose a 3 and n is 6. 3 square is 9, modulo 6 is 3. So a square is equal to a basically, okay? Under mod 6. So I will say you a n. For that, can you say me an idempotent that a square is congruent to mod a under
Wait.
mod 9?
I can't hear you from Wait. Can you write this?
Right.
Here you go.
N is 6, okay? So what is 3 square? Under modulo 6. It is fine? So these kind of elements are called idempotents whose square is equivalent with themselves. So now when I speak a n, can you say is there any idempotent or not? Or n equal to 8, you cannot find any idempotent from 2 to 7. Okay? 2, 3, 4, 5, 6. So is there any classification of those kind of n?
That's an interesting question. So if you don't know, I believe idempotent basically means applying the same information twice gives you the same result as if you applied it once. So I actually don't know if there's a special classification for numbers like this.
N cannot be prime, that's for sure. But when composite, how it can be? I know the answer for nilpotent. Actually, while doing the ring theory, the question arises in my mind, but no one could answer it.
No, I don't believe there's a classification for this kind of number.
One must is this composite, but we have to find. Suppose 15 square under mod 20 is very easy to find. That's
Yes.
15, but it's a little bit harder,
Yes,
I think.
that's interesting.
So you can think of this.
Let me think about this.
Suppose n is divisible by some square of prime or composite in a special form. Right.
So
When you write 6, you have 3, but when you write 8, you don't have any choice left for it. So what can be the ends?
let's see. So n equals okay. So let me
Except 0 and 1.
So let me see if I can write this down. So essentially a squared is not congruent to a. So mod n. So let's see. What would that require? Well, that would require, let's see, a squared minus a to be divisible by n, or a squared minus a equals some number k times n. So a squared equals a plus kn. Oh, wait a second. Okay, so that means k times n has to be equal to a minus 1 times n for whatever k. So that means that either it's k equals, so that means either n equals a minus 1 or n equals a, unless a has a few factors. Unless a minus 1 has a few factors. So yeah, this seems like too broad for any kind of classification, but it's a very interesting idea.
Suppose n gives a 36, so you have to take time for finding the a. You cannot say it directly.
Well,
So I am working on
okay.
this basically.
So if n is like
36. Now find some a that a square equal to a from 2 to 35.
Okay, so that can't be that hard, right? So let's see. So you can have, oh right.
It exists.
So let's say n equals a minus 1. So let's say a equals 36. Wait, no, but that's not the point. Okay. So let's say a equals 7. So then 36k is equal to 6 times 7. So 36k equals 42. And it should be pretty trivial to find that k equals, wait a second. Oh, that is an interesting problem. Yeah, I think it's probably pretty hard to.
It's not an instant kind of situation,
No.
I think. It's very harder.
Yeah.
Euclid's lemma or something, I don't, this is a special question I think that arises in my mind.
Yes, of course it is. So, it's only very special classifications, I think. And that would also require either a squared minus a equal to n, which is very rare, or a squared minus a is greater than n. So then that's very specific. So that limits you to a small group of numbers. Like for example, for n equals 36, a squared minus a is greater than n, or 36, then for that to happen, it must be probably 49 minus 7 is 42. So a has to be greater than 7. Okay. Yes, this is very interesting, but it might be too broad.
Shubham, let's take another question.
Yeah.
Yeah, that is better. Any more questions?
Any more